Sodium acetate is super easy to make. That's what it looks like. First, we're going to take some sodium bicarbonate, otherwise known as baking soda. This can be made a lot of different ways. This is just one way to do it. Then we're going to take some 5% acetic acid, commonly known as vinegar. We are going to react these two until there's no reaction. You're going to notice the foaming. This is carbon dioxide being released from this. Benefit to Erlenmeyer flasks is being able to do this. Added in small amounts, you're going to fizz it over if you go too fast. I've done that a few times as well as anyone else who's made something like this. Still reacting a bit. And we're going to do just a little bit more. It's okay to have a little bit extra after it, depending on what you're trying to make, I guess. I mean, everyone's got their own uses for this stuff. Okay, we're still seeing a tiny bit reaction. Shake this. We're going to do one more addition. And no reactions happening. Now we put this on a heating mantle, and we are going to boil away all the water. It's going to take a little bit to boil, so I'm going to cut this and show you when it's getting closer to done. Alright, you might run into this situation. Sodium acetate will sometimes form a supersaturated solution in water. So it means this should be crystallizing out right now. It's basically just sodium acetate. Hardly any water in there. But I'm going to need to figure out a way to break this up. One way to do it is to add some alcohol. So I'm going to do that and see what happens. Okay, this, luckily, I just have a random Tupperware jar full of anhydrous ethanol. I'm going to just take some of this. Adding alcohol to the solution will sometimes help break this up by using it as a solvent. This will form a different azeotrope with the water. And it should carry out the rest of the water, leaving behind a crystallized sodium acetate. I've been boiling the crap out of this for the last while, and ran into this super saturation issue. Some of you might not run into it, some of you do. It doesn't do this every time. Like this little tiny amount I did right before, didn't do that. But I'm going to now boil off all the ethanol water mixture, and that should crystallize everything out. Finally done crystallizing this, you'll be left with a white powder, and that will be your sodium acetate. It'll actually be in the trihydrate stage. To get it to anhydrous, and this is actually anhydrous, there's a step I skipped because of my phone battery. Put it in the oven for about 350 degrees Fahrenheit, and it'll drive off the rest the water and make the anhydrous version. This is the basic reaction that's going on. This is sodium acetate. You got your acetate and then your sodium right there. This is sodium bicarbonate, which will react with acetic acid. The sodium right here will react with the acetate ion to make sodium acetate. And the carbonate right here, bicarbonate, will go over to the H here and then make carbonic acid, which technically right here you could, if you could stabilize carbonic acid, you do have an equilibrium. So this could go back and forth depending on if you could stabilize this. However, you're not going to be able to stabilize this very easily, especially in an amateur lab. And so carbonic acid is going to break down into H2O and CO2, thus locking in this reaction, making it so you're not going to be able to go reverse because the carbon dioxide is going to bubble away. And that's the bubbles that we get at first. It's important to know this because you may want to do this reaction not to get sodium acetate. Maybe this is your easiest way to get carbon dioxide and you need that for some type of reaction, or maybe you have a way to stabilize carbonic acid or whatever you need to know. However, this is not the only way to make sodium acetate. You can do a lot of different things. With organic chemistry, you basically have an infinite pathway to make this chemical here. You can use sodium hydroxide as well. That works really well. I just find it's easier for me to use sodium bicarbonate, and so I want to show you guys the easiest way to do things. So that's my first YouTube video. I've been wanting to make content for a while. I've got a huge list of stuff, and I've been wanting to make a channel for a while now. I've had everything set up for about a year, and I've just procrastinated making the first video. I wanted it to be perfect. I wanted it to be better than this, but I realized it's not going to be perfect at first, and I just needed to put something out there. That's why the synthesis was crap. I was going to, put all the chemicals out in really nice fashion, have good backdrops, have a script. I had, the idea that I was going to have all the molecular structures and such, but that didn't happen this time. I just needed to produce something, and so I figure I'm going to rush it through this video and post it. So thanks for watching it. Thanks for supporting the content I'm working on making. I've got a lot of really cool stuff going on. You'll be happy that you're part of this channel. More on sodium acetate. I chose this chemical because it's a fairly easy synthesis, and I needed to do something, just any type of chemical, and that was the one I decided to choose. You can use it for a lot of really cool stuff. It's the flavoring on salt and vinegar chips. Don't eat this one, or eat stuff that you made in a lab. If you taste stuff that's in a lab, you're going to win an award. It could be a Nobel Peace Prize, but most of the time it's going to be a Darwin Award. A lot of scientific discoveries have come from scientists accidentally or purposely tasting their creations. That's how a lot of artificial sweeteners were found out. So this is on salt and vinegar chips. They can't use just normal vinegar with it because the water would make the potato chips terrible. So they use sodium acetate instead. You can also, that super saturated part that I'm going to include into here, when that happens, and if that happens or you do it on purpose, you can make a instant cold pack or instant hot pack with that. You get a little tiny metal disc in there that you can click back and forth, and you click in, it becomes a area for a crystal to grow. And once one crystal grows, the rest just crystallizes out. But it heats up really hot when that happens, and then after the pack is cooled off and you're done heating whatever part of your body, you can boil it and do it again and again and again, and just keep having that instant hot pack for whenever you want it. Other things that sodium acetate's really good for. One of the uses that I personally love about it is it's really good for a buffer solution. When you're working with some type of mixture that you're trying to create certain conditions, if it's acidic or if it's basic, it can change the whole reaction. And sometimes you need it to stay acidic. And a buffer solution will help maintain a specific pH or around that area. And you can put sodium acetate and acetic acid into different things to react with any of the byproducts to keep it acidic. It makes it so it'll take out any bases, or it'll be uh, overwhelming to even stronger acids. Like I've used it recently for keeping out with a few other things. It was keeping out hydrochloric acid out of one of the reactions because I couldn't get it too acidic for that. But if it was turned too basic, it would be a lot worse. So it's great for a buffer solution. There's a ton of other uses for it. If you have a cool use, post it in the comments. If you have no use for it, post in the comments. The comments help bring this to other people and get my content out there. Well, I'm going to stop rambling. I'm going to go piece this together and post it. I'm going to try to do it before the end of the day. It's Christmas, so Merry Christmas. Thanks.